Hi guys, welcome to today's session on linear inequations part 2. In part 1, we discussed various ways to solve an inequation question. We discussed about the various operations that can be performed such as addition, subtraction, multiplication and division, and the various steps that are involved in solving a linear inequation question. In this session, we'll be doing some practice question to further reinforce your concepts on linear inequations and to make you more confident in solving these type of questions. So without further ado, let's move to our first question. In this problem, the replacement set of x is given. So the replacement set, as we discussed, is the set of values that x can take. So here x can take values 1 to 9. So this is the replacement set, and we are asked to find the solution set for this inequation. Now so the inequation is given as -3 less than 2x minus 1 less than x plus 4. So let's solve this inequality in two parts. Let's take this part 1, so -3 less than 2x minus 1, and the second part, let's take it as 2x minus 1 less than x plus 4. So let's simplify each part individually. So our objective is to take all the like terms on one side and the unlike terms on the other side. So in this inequation for part 1, we have -1 on this side. So in order to remove that, we add 1 on both sides of this inequality. So adding 1 on both sides, -3 plus 1 would be -2, and less than 2x minus 1 plus 1 is 0. So -2 less than 2x. Now we have to divide both sides of this inequation with the coefficient of x, that is 2. And since we are dividing with a positive number, the sign of this inequality will not reverse. So dividing the inequation with 2, the right hand side becomes -1 greater than 2x divided by 2 is x. So x -1 less than x, or we can write it as x is greater than -1. Now let's tackle the second part. So 2x minus 1 is less than x plus 4. So now in order to remove x from one side of the inequation, we add a minus x on both sides of this inequation. So adding a minus x on this side, 2x minus x is x. So x minus 1 greater than x minus x is 0. So only 4 remains here. And then in order to remove 1 from this side of this equation, we add 1 on both sides of the this inequation. So x minus 1 plus 1 is only x, and 4 plus 1 is 5. So x greater than -1 and x less than 5. So we can write x in this format: x less than 5 and x greater than -1. So let's write the solution set for this inequation then. So the solution set would involve, so from this replacement set, the condition, the elements that satisfy these conditions would be 1, 2, 3 and 4. Only 4 of these elements will satisfy the given condition, since x is less than 5, not equal to 5. So 5, the solution set cannot contain the value 5. So this is the solution set for this given inequation. So let's go and attack the next problem. So in this question, two sets are given, two sets of inequations are given, an equation set A and equation set B, and we are asked to find the range of the set A intersection B and represent it on a number line. So first of all, let us simplify the inequation for A. So for A, it is given as 11x minus 5 is greater than 7x plus 3. And here it is said that x belongs to a real number. That means x can assume any value on the number line. So let's simplify this one. So 11x minus 5 greater than 7x plus 3. Let's try to get x on one side of this inequation. So to remove x from the second side, we'll add minus x to both sides of this inequation. So 11 minus 7 is 4x, minus 5 is greater than 7x, minus 7x is 0, and plus 3 remains. So 4x minus 5 is greater than 3. Now in order to remove minus 5 from the left hand side of this inequation, we add 5 to both sides of this inequation. So 4x minus 5 plus 5 is 0, is greater than 3 plus 5, that is 8. Now to get the value of x, we need to divide both sides of this inequation with the coefficient of x. So we divide both sides of this inequation with 4, and since we are dividing it with a positive number, the sign of the inequation does not change. So x is greater than 8 over 4, that is 2. So we get x is greater than 2. Now let's try to solve the second inequation, that is inequation B. So here the condition is given as 18x minus 9 is greater than equal to 15 plus 12x. So again, let's first bring all the x terms on one side of this inequation. In order to do that, we add negative 12x on both sides of this inequation. So 18x plus negative 12x would be 6x. So 6x minus 9 is greater than equal to 15 plus 12x, and then a negative 12x would be 0, so only 15 remains. Now our next objective would be to get all the constant terms on one side of this inequation. In order to do that, we add 9 on both sides of this inequation. So 6x minus 9 plus 9 would be only 6x, greater than equal to 15 plus 9, that is 24. So 6x greater than equal to 24, or x is greater than equal to 24 over 6, that is 4. So x is greater than equal to 4 and x is greater than 2. So the common solution for this intersection, that is the common solution, would be x greater than 4, because let's try to use the number line and solve this one. So we have x greater than 2 and x greater than equal to 4. So x greater than 2 we can denote with an open circle and an arrow on the right side of the number line. X greater than equal to 4 we can use a closed circle and an arrow to the right of the number line, and the common area is x greater than equal to 4, and so x greater than equal to 4 would be the solution for this equation, and this is the plot on the number line. So now I hope this is clear. So we'll move on to our third question. Now we'll talk about a word question. It's a very important to understand and actually convert a word problem to a algebraic equation. So let's try to do that. So it's given John needs a minimum of 360 marks in 4 tests in a mathematics course to obtain an A grade. So to obtain an A grade, his total marks, which we can represent by T, must be a minimum of 360. So it should be greater than equal to 360. So that is his total marks, and it consists of 4 tests. So test 1, let's put it as A, test 2 as B, test 3 as C, and test 4 as D. So the summation of all these tests should yield a marks of greater than 360. So now it is said that on his first 3 tests he scored 88, 96 and 79 marks. So 88 plus 96 plus 79 plus D must be greater than equal to 360, or D must be greater than equal to 360 minus 88 plus 96 plus 79. So it should be 88 plus 96 plus 79, that comes to be 263. So D must be greater than equal to 360 minus 263, or it should be greater than 97. Now what is asked in this question is what should be his score on the fourth test so that he can make an A grade. So his minimum score should be 97, or he should score more than 97. So the answer for this question is more than 97, more than or equal to 97, or we can write greater than or equal to 97. So I hope this question is clear to you. If that's so, then let's move on to the next question. So in this question it's given, find three largest consecutive natural numbers such that the sum of 1/3 of first, 1/4 of second, and 1/5 of the third is at most 25. So three consecutive natural numbers, let's say we take three consecutive natural numbers. One is x minus 1, the other one is x, the other one is x plus 1. So these are the three largest consecutive natural numbers. Let's say we take that, but we'll talk about why largest is given a little bit later. But first let's form the equation here, such that the sum of 1/3 of the first, so 1/3 of this, 1/4 of the second plus 1/4 of this second, and 1/5 of the third, so 1/5 of the third is 1/5 times x plus 1, is at most 25. So it should be less than or equal to 25. So the maximum value is 25. So we need to find the largest consecutive number. So let's simplify this further. So x over 3 minus 1 over 3 plus 1 over 4x, or x over 4, plus x over 5 plus 1 over 5 less than equals to 25. So we learned the rule that whenever we have fractions in our inequation, we need to remove the fraction by multiplying the both side of this inequation with the LCM of the fractions. So here the LCM would be 60. So we'll multiply both sides with 60 because the LCM is equal to 60, LCM of 4, 5, and 3. So when we multiply by 60, then we get so 20x minus 20 plus 15x plus 12x plus 12 is less than equals to 25 times 60. So now let's simplify this further. So 20x plus 15x plus 12x, so that is 35, 47. So 47x minus, we have 20 plus 12, so minus 8 is less than equals to 25 times 60. So 25 times 4 is 100, 25 times 2 is 150, so 150, and we have 1500, or we can write it as 47x is less than equals to 1500 plus 8, so 1508, and then we can write it as x is less than equal to 1508 divided by 47. So 1508, if we divide 1508 divided by 47, we get the value as 32. So we get it as approximately 32, or 32.1. approximately we get it like this. and then the largest consecutive number that can actually satisfy this inequation is x less than 32.1, so the integer would be 32. So 32, 31, so 31, 32 and 33. So these are the maximum or the largest natural numbers that will satisfy this condition. So I hope this question is clear to you. So with this understanding, let's move to the next question. So in this question, it is given as 1/3 of a bamboo pole is buried in mud and 1/6 of it is in water. So what is the part that is above water? So let's first find out the part that is above water. So if 1/3 of the bamboo is buried in mud and 1/6 is in water, so and the total is 1, so the part above water would be 1 minus 1 by 3 minus 1 by 6. So we can write it as 6 over 6 minus 2 over 6 minus 1 over 6. So 6 minus 2 minus 3, so that is 6 minus 3, so 3 over 6 or 1 over 2. So and then what it is given that, and the part above the water is greater than or equal to 3. So if say let's say the pole is x meter long. So if the pole is x meter long, so x divided by 2, or the part that is above the water, is greater than or equal to 3 meters. So that is given the part above the water is greater than or equal to 3 meters. So x over 2 greater than equal to 3 meters, or x must be greater than or equal to 6 meters. So here the length of the shortest pole, so therefore since the length can be anything that's equal to 6 meter or that is more than 6 meters, so the shortest pole length would be 6 meters. I hope that is clear to you. So let's take a look at the next question. So solve the given inequation and graph the equation on the number line. So it is given as 2y minus 3 less than y plus 1 less than equal to 4y plus 7, and it is given as y belongs to a set of real numbers. So let's solve this inequality in two parts. So let's do the first part. First part is 2y minus 3 is less than y plus 1. So now let's try to bring all the like terms on one side and the unlike terms on the other side. So to get y on one side, let's subtract y from both sides of this inequation. So 2y minus y becomes y minus 3 less than y minus y 0, and there's a plus 1 here. So y minus 3 less than 1. Now to bring all the constants on one side of the inequation, we add 3 on both sides of this inequation. So y minus 3 plus 3 leaves only y on this side, and 1 plus 3 leaves 4 on this side. So from this side we get y is less than 4. Let's take the second part of this inequation. So y plus 1 less than equals to 4y plus 7. So again we want to get all the y's on one side of this inequation and all the x or all the constants on one side of the inequation. So to get that, let's subtract y from both sides of this inequation. So y minus y is 0, so 1 less than equals to 4y minus y is 3y plus 7. Now to get all the constants on one side of the equation, we add a negative 7 on both sides of this inequation. So 1 minus 7 is minus 6 less than equals to 3y, and 7 minus 7 is 0. So now to get the values or the limits of y, we divide both sides of this inequation with the coefficient of y, that is 3. So, and since we are dividing with a positive number, we are not changing the sign of this inequality. So negative 6 divided by 3 is negative 2, less than equals to 3y divided by 3 is y. So from here we can write y is greater than or equal to minus 2 and y is less than 4. So y would be greater than minus 2 and y is less than 4. So y greater than minus 2 and y less than 4. So we can represent it in this way. And in the number line, let's try to plot this in the number line. So y will range from minus 2, it can equal minus 2, it cannot equal 4. So if we take the number line here, so if we take the number line here, so y can equal minus 2, so we put minus 2 in a closed circle, and 4, y cannot include the value 4, so we put 4 in an open circle, and this area is where the values of x can lie. So in order to represent this in a number line, we can put it as an open circle on 4 and a closed circle on 2, and this area is the solution of this problem in the number line. So now let's look at the next question. In this question, the inequation is given 2x minus 5 less than equals to 5x plus 4 less than 11. In such inequations, we solve it in two parts. So let's solve the first part. 2x minus 5 less than equals to 5x plus 4. So first of all, we want to get all the like terms on one side and the unlike terms on the other side. In order to do that, let's subtract 5x from both sides of this inequation. So 2x minus 5x is minus 3x, minus 5 is less than equal to 5x minus 5x is 0, and only 4 remains on this side of this inequation. Now we want to get all the constant terms on the other side of the inequation. In order to do that, we add 5 on both sides of this inequation. So minus 3x and minus 5 plus 5 is 0, less than equals to 4 plus 5, that would be 9. So minus 3x less than equals to 9. Now we want to get the value of x, so we will divide both sides of this inequation with the coefficient of x. So here the coefficient of x is minus 3. We divide both sides of this inequation with minus 3. So x, and since we are dividing with a negative number, the sign of this inequality will reverse. So x greater than equal to 9 over minus 3, that would give a value of minus 3. So x greater than equal to minus 3. Now let's solve the second part of this inequation. 5x plus 4 is less than 11. So we want to get all the constant terms on the other side of this inequation. In order to do that, we add negative 4 on both sides of this inequation. So 5x plus 4 minus 4, that would be 0, and 11 minus 4, that is 7. So 5x less than 7. So now we want to get the value of x, so we divide both sides of this inequation with the coefficient of x, that is 5. So 5x, so we get x less than equals to 7 over 5, and since here it says that x belongs to integer, so x, will write it in terms of integer, that 1 over 2.5 to 1 whole 2 over 5. So x less than 1 whole 2 over 5, x greater than equal to minus 3. So if we put it in a number line, let's let this be 0, minus 1, minus 2, and minus 3 here. So it can equal minus 3, so we'll put it as a closed circle here. We'll put an arrow on this side, and the value will be up to 1 whole 2 over 5, but since an integer is asked, so it can only take value up to 1. So we'll take 1, and here also we'll get a closed circle. So these integer values x can take, and we can write the solution set as -3, -2, -1, 0, and 1. So these are the solution set. This is the solution set for the given inequality. I hope this question is also clear to you, and with this we move on to our next question. So given x belongs to real number, solve the inequality and graph the solution on the number line. So the inequality is given as -1 less than equals to 3 plus 4x and less than 23. So this inequality we can solve it in one line, since only one side contains x. So we need to remove this constant from the middle. In order to do that, we add a -3 on both sides of this inequality. So -1 minus 3, that would be -4, less than equals to 4x, and then we have 23 and a -3, that would make it a 20. So -4 less than equal to 4x less than 20, and now we want to get the value or the range of x. In order to get that, we need to divide both sides of this inequation, or all sides of this inequation, with the coefficient of x. Here the coefficient of x is 4. It's a positive number, the sign does not get reversed. So -4 divided by 4, it gives a -1, less than equals to 4x over 4, that gives x, and less than 20 over 4, that is 5. So this inequation comes down to -1 less than equals to x less than equal to 5. Less than 5, and since x belongs to real number, we can it can assume all values in the number line. So we can represent it in the number line as this. So we have the number line here. This is 0, this is -1, and then this is 1, 2, 3, 4, and 5. So on 5, since it cannot take the value 5, we keep an open circle. Since it can take the value of -1, we put a closed circle, and this is the area that the number can satisfy. So in the number line, this is the solution of this inequality. Again, I think this should be clear, and we move on to our next question. So solve this inequation and represent the solution on the number line. So the inequation is -3 plus x less than equals to 8 over 3x plus 2 and less than equals to 14 over 3 plus 2x. Now since all these terms involve a number x, we'll solve this in two parts. So let's do the first part. -3 plus x less than equals to 8 over 3x plus 2. So now, as we know, since we have a fraction in this inequation, we need to simplify this fraction by multiplying appropriate factor on both sides. Here the appropriate factor is 3, so we'll multiply both sides of this inequation with a +3. So -3 times 3 is -9, plus x times 3 is +3x, less than equals to 8 over 3 times 3 is 8, so 8x plus 2 times 3 is 6. So we have -9 plus 3x less than equals to 8x plus 6. Now we need to bring all the like terms on one side. So in order to do that, we add a -3x on both sides of this inequation. So this side becomes -9, because plus 3x and a -3x is 0, less than equals to 8x minus 3x, that is 5x, and plus 6. Now to bring all the constant terms on one side, we add -6 on both sides of this inequation. So adding a -6 on this side makes this side a -15, and less than equals to 5x, and then to get a range of x, we divide both sides of this inequation with a +5. So ultimately the inequation becomes -3 less than equals to x, or we can also write it as x is greater than or equal to 3. Now let's solve the second part of this inequation. So the second part is 8 over 3x plus 2 is less than equals to 14 over 3 plus 2x. Again, in order to simplify that, we multiply it with an appropriate factor, and here the appropriate factor is 3. So 8x plus 2 times 3, that becomes 6, is less than equals to 14 plus 2 times 3, that is 6x. So we have a 6x here. So now we want to put all the like terms on one side, the unlike terms on the other side. In order to do that, we add a negative 6x on both sides of this inequation. So 8x minus 6x, that is 2x, plus 6 is less than equals to 14 plus 6x minus 6, that leaves only 14 on this side. Now to get all the constant terms on one side of this inequation, we add a negative 6 on both sides of this inequation. So 2x plus 6 minus 6, that keeps it only 2x, less than equals to 14 minus 6, that is 8. So 2x is less than equals to 8, or x, we divide both sides by negative 2, x would be less than equals to 4, and so the final inequation becomes x less than 4 and greater than 3. So it on both sides we have a equal to sign, so the range of x would be from 3 to 4, and since it represent only integers, so the only solution for this inequality is 3 comma 4, and on the number line that would only take the values of 3 and 4. So if we plot a number line here, if this is 0, 1, 2, 3 and 4, so the solution is two closed circles here at 3 and 4 and the region in between 3 and 4, but since it's only integer, the only values that it can assume are 3 and the value 4. So with this, we'll move on to the next question. So in this question, it's given that find the greatest integer which is such that 7 added to its double, the resulting number becomes greater than 3 times the integer. So from this word problem, let us get an algebraic expression of this problem. So we'll find the greatest integer which is such that if 7 is added to its double, so 7 plus 2 times x. So first of all, the assumption is let the integer be x. So we'll take the integer to be x. So 7 added to twice or its double, so 7 plus 2x, the resulting number becomes greater than, so this resulting number is greater than 3 times the integer. So 7 plus 2x is greater than 3 times the integer. So let's solve this inequation first. So 7, we want to get the x on one side, so we add a negative 2x on both sides. So 7 plus 2x minus 2x leaves it at 7, and 3x minus 2x, that is x. So 7 greater than x, or x is less than 7. So x is less than 7, if we plot it in a number line, so it will take the value. So if this is 0, 1, 2, 3, 4, 5, 6 and 7, it cannot take the value of 7, but it can take any value that is less than 7. So here we'll put it as an open circle, and we indicate a arrow on the left side of this number line, and the greatest integer that it can take, as we can see, is 6. So the answer for this question is 6. So with this, we come to the end of today's session. I hope through these practice questions you were able to reinforce your understanding of linear inequations. We solved both word questions and number questions here, and I hope with this understanding you will be able to attack linear inequation questions more confidently. Thank you so much for joining today's session, and we'll see you again in our next sessions. Thank you. Goodbye.